Number 41, predict which compound in each of the following pairs of compounds is more acidic and explain your reasoning for each. Then we have letter D. So in this case, we just have to find out which compound is more acidic. Is it NH3 or is it PH3? Well, in order to decide that, we first got to put these acids into a type of category. For Gen Chem, there's generally two types of acids that you're going to come across. They are binary acids and oxoacids. We'll start with binary acids and see if it fits the mold. Binary acid is when you see a hydrogen and then you see another element. The idea here is that binary means two, right? Bi in chemistry means two. So you're only allowed to have two different elements. I don't care how many hydrogens I have. I just have to see that there's an H and that there's another element. So let's see. For NH3, there's an H and then there's a nitrogen. That's a binary acid. For PH3, there's an H and there's phosphorus. That's two elements. That's a binary acid. So we're dealing with binary acids here. Now the trend for binary acidity is as you go down a group on the periodic table, your acidity will increase. Now, which elements are you going to pick out to do this trend? Well, since they both have hydrogens, that's not difference between them. You're looking at the differences. So you're going to stack up nitrogen against phosphorus. So those are the elements that you look for on the trend. So let's just say if nitrogen is up top here on the periodic table, phosphorus is in the same group, but just below. So just put them together. As you go down, your acidity increases. So which one is more acidic? The phosphorus or the nitrogen? It's the phosphorus. As you go down, you increase in acidity. So the more acidic one here would be PH3. But now we just need to explain the reasoning, right? Why does this actually happen? And this is linked with the atomic radius. I don't know why, but I really like to explain this idea. I think it's pretty cool. But anyway, as you go down a group, your radius of the atom will also increase. So if you put this into perspective, let's just say that we have N and then we have P, right? So let's just put a little dot for nitrogen. But as we go down, the radius increases, phosphorus would be bigger, right? You see how the radius has gotten bigger as we went down? And if we kept going down, it would be bigger and bigger and bigger. So if I had to draw these two, I'll give a big circle for the phosphorus. So I'll just label this as PH3. And then we need a small circle or a smaller circle for the nitrogen. So we'll say this one is NH3. Now, here comes the hydrogens. Hydrogens are very, very, very small. So I'm going to put like a single little dot here to represent the hydrogen bound to the nitrogen. And then it's got to be the same dot because hydrogens are a hydrogen. It's bound with the phosphorus. Now, if we look at the bonds, right, from a hydrogen to a nitrogen, look at that length. And then let's look at the length between the hydrogen and the center of the phosphorus. Now, it seems that the bonds between the hydrogen and the nitrogen, they're very close. They're closer than PH3. So these have close bonds, close, tight bonds, right? Between the hydrogen and the nitrogen. And then if we just, analyze this, they're farther away. So we'll say maybe not close. I don't know. Farther away bonds, longer bonds. The idea here is that it's not as close. Now, keep in mind with what acids do. Acids, coming back up to this idea here, acids love to donate the hydrogen. Acids want to give away that hydrogen. So if they want to give away the hydrogen, it's got to be easy for them to give the hydrogen away. But if we talk about it in terms of closeness and close bonds, if you have somebody in your life that's very close to you, right? Look at this close, tight bond. And if they just one day got up and left, how would you feel? I mean, for me, I would be devastated, right? But remember, that's what acids like to do. They want their hydrogens to leave. But if you have a close bond, that's not happening. the nitrogen is holding on to that hydrogen. But in terms of here, since the hydrogen is farther away and this hydrogen tries to leave, the phosphorus is like, that's fine. I'll recover. That's the whole idea here. So it's because phosphorus has a larger radius that hydrogen is easier to be donated. I hope that gets across. Let me know in the comments if that makes sense or not. But that's the answer, guys. Hopefully this helped. Thank you so much for tuning in. Subscribe to the channel if you want to help us out. We're almost at 20,000 subscribers. That's nuts. That's absolutely nuts. I would have never thought that an education channel would even get 1,000 subscribers. So thank you so much. You guys rock. I'll see you all later. Have an awesome day. Bye-bye.